We've all seen them, those beautiful unexpected streaks in the night sky as a particle no bigger than a grain of sand enters our atmosphere at high speed and vaporizes 60 miles above our heads. You might be surprised to learn that over 48 tons of meteoritic material enters the Earth's atmosphere every day, most of it burning up before it even gets close to the ground. Our thick atmosphere is a wonderful shield against these cosmic bullets. The truth is, not all the objects out there are as small as a grain of sand. There are objects that are miles across within the family of objects that cross Earth's orbit and have a chance of hitting us. To see the result of not having a thick atmosphere to protect you, just take a look at the moon. It is a completely battered object that records an impact history going back billions of years, and it's still happening. It's the tail end of the process that actually built the planets up from the primordial solar nebula. It's also the process that had an important role in shaping the history of life on Earth today. Tons of sand and dust-sized particles enter our atmosphere every day, but as the size of the object goes up, the less frequent they are. Objects 4 meters in diameter hit us with a frequency of about 1 every 1.3 years. Increase the diameter to 20 meters, and you can expect an event every 60 years. Luckily, on average, any object smaller than 100 meters in diameter would be expected to disintegrate before hitting the ground. However, that doesn't mean they're harmless. The Chelyabinsk event over the Urals in 2013 was caused by a 20-meter-sized object traveling 11.9 miles per second. It exploded at an altitude of about 92,000 feet with an energy of 400 to 500 kilotons, breaking windows and causing injuries over a wide area. On June 30th, 1908, an object approximately 100 meters in size exploded at an altitude of 3 to 6 miles above the Tunguska River in Russia. The blast devastated over 800 square miles of mostly uninhabited forests. As you can see, an object does not have to reach the ground to do tremendous damage over a large area. Impactors slightly larger than the Tunguska object do make it to the ground, creating even more devastation. When an object 130 meters in size hits the ground, it vaporizes. All of its kinetic energy is released in a 30 megaton explosion, 2,000 times the energy of the Hiroshima bomb. Even from 15 miles away, the effects would be significant. Thermal radiation would cause second-degree burns, igniting trees and grass. The ground would shake at a magnitude 6.3, and the shock wave would collapse multi-story buildings. The damage is localized but intense. An impact of this magnitude can be expected every 11,000 years. Truly large events, such as the impact that is thought to have caused the end of the dinosaurs 66 million years ago, have global effects. The Chicxulub impactor was approximately 15 kilometers in diameter. The impact caused a 100 million megaton explosion that resulted in the extinction of 3/4 of all animal and plant life on Earth. No land animal heavier than 55 pounds survived. The dinosaurs were gone forever, and the Earth's ecosystem was changed. While these events are devastating, they're a part of what made the Earth as we know it. It is thought that much of the water on Earth today was delivered by the impact of comets. Our moon is thought to be the result of an encounter with an object the size of Mars. It's even possible that life itself, or the compounds that make it possible, were delivered by impacts. Currently, scientists are devising ways to prevent dangerous impacts in the future. The orbits of most Earth-crossing asteroids are tracked, and more are found every day. If a dangerous object is predicted to have a chance of hitting us, its orbital path can be changed through various methods to turn a disaster into nothing more than an interesting astronomical event. The dinosaurs couldn't do it, but we can.